let's talk about something we use every single second of every single day. But here's the thing, almost everything we think we know about how electricity works, well, it's wrong. Today, we're going to pull back the curtain on the surprising, kind of counterintuitive truth about what's really happening inside the wires all around us. Okay, just think about it for a second. You walk into a dark room, you flick a switch, and boom, the light on the other side of the room turns on instantly. It feels immediate, right? Like it's moving at the speed of light. But what is actually happening in that split second? And this is where things get really weird. Our first big paradox. The effect, the light turning on, feels instantaneous. But the things we all picture racing through those wires, the electrons themselves, they're actually drifting along at an incredibly slow pace. Yeah, literally slower than a snail. So how can both of these things possibly be true at the same time? Let's unpack this. To really get our heads around this modern confusion, we've got to rewind the clock. Turns out, our most basic idea of electricity is built on a total guess, made long before we even knew what an electron was. This is just fascinating. We had it completely backwards for over 100 years, all based on a 50-50 guess. Back in the 1700s, Ben Franklin imagined electricity was some kind of fluid flowing from positive to negative. And that idea, they called it conventional current, it just stuck. It wasn't until 1897 that J.J. Thomson actually discovered the electron and proved the flow was the other way around, from negative to positive. So to try and make sense of all this, we often lean on that classic water analogy. And look, it's a helpful way to start, but as we're about to see, it's also where the real picture starts to get, well, a little blurry. This chart breaks down the basics perfectly. Voltage is like the water pressure, the push. Current is the flow rate, how much water is moving. And resistance, that's just a narrow pipe that slows things down. It's a really useful model, but it also reinforces the biggest misconception, that something is physically traveling all the way down the pipe. And that's the exact idea we need to challenge. So, if the electrons aren't just pouring out of the battery and racing to the light bulb, where do they come from? The answer is so simple, it's almost funny. They're already there. They're packed inside the wire itself. The scale we're talking about here is just mind-boggling. In a tiny little cubic centimeter of copper wire, you have over 84 sectillion copper atoms. That's an 84 with 21 zeros after it. And every single one of those atoms has a part to play in this story. Right, so this is crucial. A copper wire isn't some empty pipe waiting for electrons to get pushed into it. It's more like a pipe that's already completely jam-packed with water. The wire is a dense grid of copper atoms, and each one has a free electron in its outer shell that can just pop off and move around. So before you even flip the switch, this giant sea of electrons is just bouncing around randomly, going nowhere in particular. The wire is perfectly neutral, no charge. It's a system just waiting for an order. So if the electrons themselves aren't the fast-moving messengers, what is? Well, the answer is something you can't even see. It's an invisible force field that fills the entire circuit the very instant it's completed. This field is the real star of the show. See, a battery works with a chemical reaction that yanks electrons over to one side, the negative terminal, and leaves a shortage on the other, the positive terminal. This separation of charge creates a kind of tension, an electric field that spreads out from the battery, ready to do work. It's a force that can act at a distance, without anything touching. And here it is. This might be the biggest misconception of them all. The energy that powers your lamp isn't being carried like a little backpack by individual electrons. No, the energy is transmitted through the electric field that forms around the outside of the wire. This field gets set up by a pattern of charges that builds up on the wire's surface, and that's what creates the force that pushes the electrons already waiting inside. Okay, now we have all the pieces. We can finally put them all together and solve that central mystery. How can the effect be instant if the flow is so ridiculously slow? Let's just ask it one last time before the big reveal. The light comes on now, but the electron that just left the battery, it might take hours, maybe even days to ever get to the bulb. How on earth is that possible? First, let's just look at the speed of that single electron. Once you close the circuit, an individual electron has a drift speed of less than 1/10 of a millimeter per second. It's basically crawling. But now, look at this. The electric field, the signal that says, "Go!" propagates through that wire at nearly the speed of light. The difference between these two numbers couldn't be more dramatic. So here's exactly what happens. The moment you flip that switch, you complete the circuit. That command, the electric field, travels at almost light speed. This field doesn't just push one electron at the start of a long domino chain. It gives a simultaneous nudge to all the free electrons everywhere in the circuit all at once. Think of a long train. The engine moves and the very last car moves at the exact same instant. The electrons that are already waiting inside the lamp's filament are the ones that start moving and create the light. The effect is instant, not because one electron made the whole trip, but because they all started moving together. And that brings us to a final, pretty cool thought. The copper wires in your walls are full of electrons that have been there forever. You don't own them. The power company doesn't send you new ones. What they do is provide the energy stored in that electric field to organize the chaos of the electrons that are already in your home's wiring and get them to do useful work. So what you're really paying for is the energy to create that invisible, instantaneous, and incredibly powerful push.